Hello everyone, how are you all doing? Well, in today's video, let's discuss the next part of functions. Here we have the topics. Universal set, union of two sets, intersection of two sets, and a complement of a set. They're not as hard as you're thinking. Let's begin. Universal set. Now, before I clear the concept of universal set, there's something that you found on the screen, that is the Venn diagram. Now, you must be aware of many like this from grade 10, right? Firstly, consider this circle. Let's say this is set A. Fine. That means the elements that are present in this yellow color boundary, alright, yellow color area across a green color boundary, this comprises the elements that are in A. Alright, now I'll quickly erase this. Now I'll say this part over here. Let's say this is set B. And this green color boundary comprises the elements in B. Alright, fine. Now one of my friend asked me, what is this part then? Is this the extra part? No. It is comprising the common elements in A and B. Now this is something that you must be aware in order to understand universal set in the form of a Venn diagram. That would actually build up clarity in your mind. Alright, so put this into your mind right away. Now let's understand the concept of universal set. Here I have two sets. Let's suppose say A equals to 1, 2, 3 and B equals to 3, 4, 5. Now we are going to find out the universal set, which is generally represented by capital U. Now firstly let's represent this over here. This is set A and this is set B. I am putting down all the elements 1, 2, 3. Now you might ask me, why did I put 3 in this lonely place? Well, it's because 3 is both present in A and B. So this is the common space for A and B, isn't it? So here we'll have our 3. Now 4 and 5 are present in B, so 4, 5. In this way you represent A and B sets. Alright. Now unfortunately, I added few elements over here. Out of these two sets, I have added 6 and 7. Now, the whole set that is there, that is becoming the universal set. Now, what does this mean? All the elements in this boundary right now are comprising in the universal set. Are we getting? Now, let's suppose say this is a blue color boundary and the elements which are in this blue color boundary, all of A, P and extra elements that are there, they comprise the universal set. Now what is our universal set over here? Well, it's going to be 1, 2, 3, 4, 5. Also, we had two other elements which are out of A and B, but they still comprises U. The U that is written on the top says that it's a universal set. Okay, you generally write it in this manner. Alright, 6, 7. Now this is called the universal set. Alright, now if I add 8, 9, it means that there are two other extra elements in the universal set 8, 9. And this is how your universal set comes into picture. Okay, all the elements that are present in this rectangular shape comprise a universal set. Fine. Now what if, just not having enough confusion in our brain, let's say this is one universal set that I have. Now what is U over here, everybody? Everything that is present in this rectangle. That means 1, 2, 3, 4, 5. As simple as that. Isn't it? This is your universal set. Irrespective of whatever is present out of these sets, the one that is present in this rectangle comprises a universal set. Now, one question that is over here is that I have 3 two times. Why don't I write 3 and okay, let's suppose say I build another Venn diagram in order to have enough clarity in what I'm speaking. Let's say these are two sets A, B, and this is a universal set. Now I have 1, 2, 3, 3, 4, 5. Why can't I represent it in this manner? Is it, it is definitely the same thing, right? But it's not. Because elements do not repeat in a set. This was the fundamental thing that we have learned in our basics, right? So this is not going to happen. Alright, and that is why we represent sets in this manner. And that is called the universal set over here. Moving forward, we have the union, intersection, and complement. Let's finish it. Union of two sets. Now here, A union B. This symbol represents union. And here it says that x such that x belongs to A or x belongs to B. That means here in three conditions, we have x belongs to either A or x belongs to B or x belongs to A and x belongs to B. If any of these conditions is satisfied, then it means the union of these two sets. Let's understand this by this Venn diagram. Let's say this is set A and this is set B. And I have 1, 2, 3, 4, 5 as the elements in this manner. Now the union of these two sets is going to be 1, 2, 3, 4, 5. Why? That is because here 1, 2, 3 belong to set A and 3, 4, 5 belongs to set B. Aren't the conditions satisfied? Yes. So this is the union of these two sets A and B. Now why didn't I represent this union in this manner? U is equal to 1, 2, 3, 3, 4, 5. That is because here you might ask me 1, 2, 3 are belonging to set A, 3, 4, 5 is belonging to set B. They completely satisfy. Why not? I can write like this. That is because here 3 is repeated. Here 3 is repeated twice. And that is not possible. The elements in the sets are not repeated. That's why here it's represented in this manner and not this. Now here the one word that you need to focus on is or. It is meaning that either x can belong to A or x can belong to B or x can belong to both A and B. Here I can take an example. Let's say set A is equal to, okay, let's take the same example 1, 2, 3 which is represented on the Venn diagram. And we have B equals to 3, 4, 5. The union of these two sets can also be 1, 2, 3. Why? That is because your 1, 2, 3 belong to set A and that is perfectly what A is union to B. Alright, I can simply say A union B. This is also the union for this set. Let's quickly take over a look on intersection. Intersection of two sets. Now here I have the Venn diagram again. Here this symbol over here represents the intersection of two sets. Let's say again we have A and B as our sets. Now here x belongs to A and x belongs to B. Here and means simultaneously. That means x should satisfy, that means x should belong to both A set and B set. Alright, now that can only be possible if they are common. That means if they are in this space. Alright. Now let's say A equals x, y, z and B equals z, a, b. Let's represent them. What are they going to be? X, y, and in this space I'm going to have z. Alright, let's have this. And on the other hand, I have A and B. That means your Z will be the intersection of these two sets. That is A intersection B equals Z. As simple as that. Why? Because there's only one common element. There's only one intersection between set A and set B, that is Z. Here and means both A and B. That means both the condition 1 and both condition 2. Matlab, if both 1 and 2 are satisfied, only then the intersection of two sets would be possible. But here arises a question in the mind. Let's say if intersection of two sets is not even possible and they're asking us to find out the intersection. Now let's suppose say this is set A and this is set B. 1, 2, 3, 4, 5, 6. Is there any common element in set A and set B? Of course not. So A intersection B will be equal to phi. Phi is the null set or the empty or void set. Okay. That means there is no such intersection of these two sets. And that's why they are known as disjoint sets. That means they do not have any intersection between themselves. That means there is no such element in these two sets which is common. Here we move on to the last concept for today, that is complement of a set. We generally denote in this way A complement. Alright, this is read as A complement equals to X is such that X is not equal to A and X belongs to U. What does this mean? Here, let's say this is set A and this is set B and we have a universal set. Fine. X should not belong to A or any other set that is present here. Here A means any other set. Okay, any set that is present in universal set. That is, you're gonna ignore all the sets that are present in the universal set. So let's put on a red mark for this. X is not equal to these elements that are in this red mark. But X should belong to universal set. All the space that is left over, that is marked by green, is belonging to universal set, isn't it? Though it might not belong to A and B or any other set that is present, but it's still belonging to universal set that is there. So this area will give you the universal set. That is, this area is going to give you the complement of a set. Fine. Generally, you find the complement of one set, right? Here, let's ignore the other set that is present. Fine. Let's make on a new Venn diagram over here. This is set A, let's say. Fine. Now here, this is the universal set. This is the universal set. Ignoring all the other sets that are present, the empty space that is there, that will become the complement of set A. Alright. Let's put on an example. If the universal set contains elements from 1 to 10, Let me write it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also, in set A, I have 11, 12, 13. Now, what is the complement of set A? That is the question. Complement of set A will be equal to what? Well, have a look at this set. Ignoring all the elements that are in the set, that will be your complement. Alright, that is simply going to be 1, 2, 3, etc. till 10. This will be the complement of this universal set. That is, A complement is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because they are all the other left out elements in the empty space that is there. You're going to ignore all the elements that are present in the set which you're going to find the complement of. And this is called the complement of a set where X is not belonging to any other set, but X should belong to the universal set. And that dives us to the end of this video. Make sure you hit the like button, share and subscribe. Thank you.